Hi everybody, Mrs. Temple here. What we're going to be working on today in Trig Pre-Calc is we're actually going to start out chapter 2 and we're going to look at section 2.1 and just look at the first example. We're going to go through the first example, both parts A and B. The notes as well as the answers can be found on a PDF under the 2.1 folder on Teams. So the first thing it's asking us to do is to go ahead and actually graph this equation up at the top, or this function up at the top, and it's 1/2 x to the 4th. The reason why I have a table here is for any problem that starts out, what I'm asking you to do is to make a 5-point table. The x values that you pick will not make a difference. Usually I just pick -2 to +2, so it gives me a various range. For this section, clearly you're at home, you guys can use a calculator. So if I go ahead and I plug in these numbers, I'm gonna end up getting 8 if I plug in -2, 0.5 if I plug in -1, 0 if I plug in 0, and 0.5 and 8 right back out. The first thing I'm going to ask you to do for any of these problems is to make that 5-point table. And then the next thing is I want you to think about what we've been doing in class, or what we've done in class throughout the year. If I'm giving you a function where there's an x variable that's raised to an even power, what I want you guys to think is this is going to have the exact same characteristics if I asked you to graph y equals x squared. What you're doing with the table is really just backing up that it should have that overall shape. If you went ahead and you connected these points, and clearly yours would be a little bit more accurate than this, you're going to end up with something that is in the shape of a parabola. So anytime your coefficient in the front is positive and your exponent is even, it could be 2, 4, 6, 8, and so on, your overall shape is going to be a parabola. Based on the points that you just plotted and knowing that this is going to be your shape, your answer for this problem is listing out these 6 characteristics. And your first one's going to be domain. Anytime we talk about domain, I would ask you to write an interval notation. It's going to be your x values. So if I go from the left to the right, what can x be? And there's arrows in both directions, so it can be all real numbers. Your range is going to be your y values. So as I travel from the bottom and go up to the top, where did I start? I started at 0. I can include 0 because 0, 0 is a point on that graph, and I'm going to go all the way up to infinity. For your intercept, you are going to notice patterns throughout this section. That 0, 0 is going to be your intercept because we're not moving the graph up, down, left, or right. And again, that point 0, 0 was over in your graph and it was the middle point anyway. For your end behavior, this is going to be our limit. So there's 2 different things that you need for end behavior. The limit of f of x as x goes to -infinity, and the limit of f of x as x goes to +infinity. So what's happening with the ends of your graph? So as x gets smaller, what's happening to y? Your y value is increasing, or it's going to +infinity. As x is going to +infinity, or it's increasing, what's happening to your y value? Your y value is also increasing, or it's going up to infinity. For continuity, are there any asymptotes in the graph? Any point where it stops? No, so it's continuous everywhere. If you remember listing continuity, it's actually the exact same answer as your range, or excuse me, your domain would be. So if you say a function's continuous and you have to tell me where, you simply answer with what your domain is. And then I'm going to ask you for increasing, decreasing. Whenever we did this, we basically read the line or the graph just like you read a book and go from left to right. So as I travel from left to right, don't look at the arrows. If I follow this graph, this entire time it's decreasing and then it stops. So I would go ahead and say that I am decreasing from -infinity to 0. Then I would go ahead and say, if I picked up here, what am I doing as x is getting larger? My y value is increasing. So you're increasing from 0 to infinity. You're going to use parentheses on these. I've seen it done both ways, but you can't really increase or decrease on a specific point. So your answer should just be in parentheses. I think the weird thing about this is, what is the answer? The answer is all this information right here. So these 6 characteristics that you look down or write down, that's the biggest part that I'm going to be looking for as you're going through your problems. By you drawing the graph or you making the table, it's giving you something to look at to go ahead and fill out these characteristics. So again, if your coefficient in the front is positive and you have an even exponent, you're going to think y equals x squared. For part B of this example, you have f of x equals -x to the 7th. Again, it will not matter which points you pick. I went ahead and did the same thing. My 5 points, your x's go from -2 to +2. And if I go ahead and I take these values, use a calculator, plug them in, I'm going to get 128, 1, 0, -1, and -128. And if I went ahead, we'll go off to the side up here, and let's say that I sketched a graph, and clearly these are not going to be completely to scale, but I went ahead and I plotted 0, 0, and I plotted the point -1, and then up 1, and then I plotted my other point, which was 1, -1. My graph would have an overall shape that looked like this. Why does that happen? If my leading coefficient is negative, and my exponent is going to be odd, it could be 3, 5, 7, 9, and so on, what we're going to think for this is going to have the same overall shape as -x to the third. I'm hoping that this makes sense because now this is a reflection as well as our x to the third graph, which looks really similar to this. So again, we're going to use this table. We're going to use what we already know of what the overall graph is going to look like, and our answer is really just going to be answering these 6 characteristics. So what's the domain of this? It's going to be all of your x values, and since there's arrows in both directions, it's going to go from negative to positive infinity. Your range for this is going to go from the bottom up to the top. So you start at -infinity, and you keep going all the way up to positive infinity. Your intercept for this, again, the same thing as the one that we just did up on top, and you can also find this in the table. 0, 0 was right in there. We're not doing any sort of shifts on this graph, so our intercept's going to be the origin. For your end behavior, again, I'm looking for the same 2 things. The limit of f of x as x goes to -infinity, and the limit of f of x as x goes to positive infinity. We're going to try to look at the graph to go ahead and fill in these blanks. So as x is getting smaller, what's happening to my y value? It's actually getting larger. So this answer would be positive infinity. As my x value is getting larger, what happens to your y value? It's getting smaller this time. So we're going to say -infinity. For is this continuous, you would say, are there any asymptotes on the graph? Is there any place where the graph stops? And that would be a no. So how you're going to answer this is you're going to look back up at your domain, and you're going to say this is continuous from negative to positive infinity. For increasing, decreasing, again, please do not pay attention to the arrows. Simply read the graph like you would a book. Go from left to right. So if I go ahead and I start all the way up on the left-hand side, what's happening the entire time with this graph? I am decreasing. So I'm going to be decreasing from negative to positive infinity. These are some characteristics we've definitely talked about before in chapter 1, just basically some inferences of what you can make from the graphs depending on the type of exponent or the sign of the coefficient that you have. Whenever you go ahead and do these problems, again, what I'm looking for are these 6 characteristics that you go ahead and fill out.